Hey guys, the day is here and we can finally talk about Intel 12th Gen performance and how it stacks up against the previous generations as well as current leading chips from AMD. Spoiler alert, it does not suck. Mostly. More on that in a bit. First, let me do a quick high-level breakdown on what's new and different in Intel 12th Gen. In our case, we'll be checking out the top of the line Intel i9 12900K. And by the way, if you're familiar with this, we'll have chapters enabled, so feel free to jump straight to the benchmarks. For the rest, let's dive in. Intel 12th Gen is now based on an Intel 7 process, which is actually Intel's 10nm technology. It features new hybrid design which consists of P and E cores. The traditional cores are now called performance cores, and the new type of cores are called efficiency cores, which are 4 times smaller on the die than P cores. There are 8 of each in a 12900K, but if you look at the spec, it mentions 24 threads. This is because the performance cores support multi-threading, while efficiency ones do not. More cores is normally better, as it allows for better multitasking, and with efficiency cores clocked lower, they're perfect for background tasks, freeing up performance cores for the more critical utilization. To further improve performance, Intel has introduced a new tool called Thread Director that helps operating systems schedule tasks to the correct cores. Unfortunately, this is only available on Windows 11 at the moment, so we'll have to see what performance difference we get. Besides adding more cores and complicating the whole core and thread count, the new P cores have reportedly 19% improvement over last generation at the same frequency, which is a pretty impressive jump. There are a couple other major changes in this generation, like for example Intel now supports PCIe Gen 5 as well as DDR5 memory. While we currently do not have any PCIe Gen 5 graphics cards, this move does seem like we may see them really soon. On the other hand, support for DDR5 is a great move by Intel, as this starts a new and gradual migration into the world of faster RAM with higher bandwidth. Few things to note: the first memory modules that are scheduled to hit the market will have pretty average performance due to low speed and high latency, but this will surely improve over time. Also, I hear that the pricing of this RAM is going to be pretty high, so we'll just have to see. Luckily for everyone, these chips still support DDR4, but you'll have to use the compatible motherboard. At this moment, it is unlikely that many motherboards will have dual memory support, and if they do, you will not be able to mix and match. You'll simply be able to use DDR4 or DDR5. Do watch out for compatibility. For example, ASUS is using D4 in their product name to indicate DDR4 support on the motherboard. Intel has also introduced new RAM overclocking profiles, XMP 3.0. They're working with vendors to validate it, and we should see many upcoming DDR5 modules supporting it in the near future. While we're on the subject of overclocking, there is a new version of Intel Extreme Tuning Utility, which has a built-in auto mode to overclock by 100 MHz across all cores for those who want to get just a little bump, allowing you also to go more granular in the manual mode. Let us know in the comments below if you'd like us to do a deep dive in overclocking and what would be your use case. With a quick overview out of the way, let's jump into our benchmarking. For the last generation PCs, we have Intel i9 11900K and AMD Ryzen 5950X with Z590 and B550 motherboards respectively. Both use mid-range Corsair RAM with 3600 MB transfer speed and CL18 timings. For the new Intel i9 12900K, we've used ASUS Maximus Z690 Hero motherboard and GEIL DDR5 memory with 4800 MB transfer speed running at 38 CL using ASUS RAM overclocking. And yes, we're using separate platforms with different RAM generations, which is likely going to skew the results ever so slightly. But remember, just because RAM is 1200 MB transfers faster, it does not automatically make it better, as DDR5 memory also has higher timings, and that contributes a lot to the performance. In all the examples, we're using the same RX 6900 XT graphics card. For cooling, we're using 360ml liquid all-in-one cooler by ASUS. As far as general settings go, we've set CPU cooler pump and fan speeds to 80% and GPU fan speeds to 75% to keep results consistent. A few more things to add. We've used the latest version of Windows 10, which I believe many enthusiasts would use for the time being, as Windows 11 has certainly had a rough start. Having said that, if Intel is to be believed, 12th generation chips should perform better on Windows 11 and improve over time as developers optimize their apps for the Thread Director. Another thing we noticed is performance difference between BIOS revisions. This is pretty expected with the new platform. We've left both results in as an example. Jumping straight into the benchmarks and starting with some games. We reduced the resolutions and graphics settings for each of the games in order to remove GPU bottlenecks and be able to really compare the CPUs. Ultimately, the goal is to show performance delta between these setups. First game is Shadow of the Tomb Raider, and here we see a significant improvement from last gen at 19% on both average FPS and 1 percentiles. We have approximately 5% lead on average FPS and 15% lead on 1 percentiles over AMD as well. Next is Doom Eternal. This game is pretty easy to run, and the large FPS count makes this kind of testing even more pronounced. In this game we see that from 11900K there is about 30% improvement on average FPS and 32% on 1 percentiles. When compared to AMD, the new CPU leads by 17% on average FPS and 10% on 1 percentiles. Another light game is War Thunder. We threw this in basically for fun as the frame rate is just insane. In this game, AMD takes a 6% lead on average FPS and only 2% on 1 percentiles. In Horizon Zero Dawn, there is only about 8% improvement on average FPS from the 11th gen and 15% improvement on the 1 percentiles. The improvement here simply matches AMD's performance. It is good, but probably won't be called the best in the world just yet. While analyzing the data, we noticed a more unexpected pattern. The frame rate is certainly competitive against AMD, and in some cases better, but the performance per watt is actually even more impressive. Here we have results of FPS per 10 watts on all of these chips across the same games. We see that in all titles, the new CPUs deliver more FPS per watt. In the heavier title Horizon Zero Dawn, the difference between AMD and Intel is 17%, and in Shadow of the Tomb Raider the difference is 51%. In the lighter Doom Eternal game we see a difference of 26%, and in War Thunder it is a whopping 68%. So far, just looking at the gaming results, I can certainly say that Intel is back and there is healthy competition happening here. This is certainly good for gamers, but is the new architecture equally good in productivity? This one is a bit of a mixed bag. Let's start with the Cinebench R23. In this benchmark, the new Intel chips are ahead of AMD's top-of-the-line 5950X in both single-core and multi-core results. And considering that Intel chip has only 24 threads against 32 from AMD, that is very impressive. In Blender, we'll also see Intel trading blows between different tests with less than 15 seconds difference between them. In V-Ray we see about 9% lead by AMD. This is where those extra threads are pushing into victory. Even though Intel 12th Gen is not leading here, it is still miles ahead of its predecessor. Next up we have 7-zip benchmark, and here AMD completely dominates on the decompression speed, but falls behind on the compression side, while Intel is a bit more balanced. It is clear that the new chips from Intel have brought major improvements in productivity tasks as well. The hybrid architecture does not yet fully stack up against the large multi-threaded beast from the competition. It is close, but not quite there yet. One thing that Intel has done is change its boost functionality. Previously it would boost for a certain amount of time and then bring itself back down. But as we see in this Blender run, it boosted for the whole duration. Even with this beast of the cooler, it reached 90 degrees straight away and peaked at 95 degrees towards the end. For reference, the room ambient temperature was 28 degrees Celsius. In terms of power consumption, this chip does not mess around. In this Blender render, it hit 224 watts and stayed there. In comparison, if we look at AMD, it is basically sipping power at 137 watts while delivering slightly better results. To sum things up, has Intel delivered on its promise? In gaming, certainly. It is even doing pretty well in productivity. So for those who spend most of their time gaming and maybe doing some productivity tasks on the side, this is an incredible leap forward. With Windows 11 and Thread Director, we can expect it to get even better. I'm glad to once again see innovation in the CPU market, and we've got AMD to thank for this with the pressure from the Ryzen processors. I'm really looking forward to seeing what Team Red brings to the table with their new chips in the upcoming release, and we'll enjoy the view of both companies leapfrogging each other yet again. And as always, if you want to check out any of the items covered in the video, the links are in the description below. I hope you found this useful. Don't forget to smash the thumbs up and subscribe for more. We'll see you guys in the next one.